It's fine.
It's fine.
Hi, everybody. This is Simon and Simon right there, and Denny, live AMA because we are alive. And we're actually here to go ahead and talk about, it's basically an extension of our Build A Thing webinar series. You may or may not realize this, but this is in fact Simon and my first time actually working together physically. We've actually only worked together online virtually this entire time. So we want to make this an interactive session. So we would like y'all to actually ask questions. It allows us to be lazy too. So it allows us to achieve both things. But in all seriousness, we hope you actually have lots of questions when it comes to Delta Lake, Delta Live Tables, Autoloader, things of that nature. Simon and his team, the cohort that's sitting up here, basically, Terry, okay, sorry. Basically, they are the awesome consultancy that actually has worked with Databricks and other, yeah, okay. Oh, right, there's a camera there, right? Okay, and so, other systems when it comes to big data systems, okay? They're passed as he's currently trying to log in because apparently he has no internet access whatsoever, is in fact actually from the SQL Server years, actually. So they actually know a lot about database and BI systems. In fact, that's actually how come Simon and I actually got along well, because I'm actually formerly SQL Server. I don't like admitting that fact, but it is what it is. So, nevertheless, are we logged in, by the way? I have no idea. No? Okay.
It'll be okay.
It'll be okay?
Yeah.
All right, cool enough. All right, fair enough. All right. So anyways, that's me going ahead and just holding the fort. And so, but nevertheless, okay, so we do want to talk about Build A Thing. So in essence, if you have your questions when it comes to, like I said, Delta Live Tables, Autoloader, anything else we should include?
And Databricks SQL.
Oh, that's right, Databricks SQL. This is the time for you to go ahead and ask the questions. So anything else you want to go before we, you could introduce yourself officially.
I think you did enough intro for me.
Really? I did?
Yeah,
well, okay, yes, that's why I'm wearing
his,
his face on my, chest.
So the only thing I wanted to do quickly is get up there we go. This is what we built.
Oh, that's right. Okay, cool.
See, I made some slides.
I know. No, yes, you're the professional. Okay,
so we did a series of, I think, 5 videos. And we went through going, right, are we going to just demonstrate how to put a lake house together? So a lot of that is what's a lake house, all of that kind of stuff. If those are questions you guys have, we can talk through it. But we built a little tiny scraper that went and talked to a web API, got some data down, and put it into a landing area. That was kind of just do a quick thing. It was Azure-y stuff. And then from there, so that was just running on a daily basis, going and scraping some data and landing some JSON files into that kind of blob landing area. And then the best thing to use, if you're trying to work out what files are coming in, what have I loaded, what have I not loaded, I'm just going and looking at a container and saying, what are the files I need to ingest? And so for that, we've got a thing called Databricks Autoloader, which is streaming. So we can stream from a file source, but efficiently, so it's only looking at the new things that have come in. And we pull that out and put that into Delta tables. And actually, that process of pulling it out and putting it into a Delta table, and then picking it up and doing some cleansing and putting it down again, and then picking it up and doing some curation and turning it into a nice, good gold curated asset. I mean, that's like our whole data preparation pipeline, right? And for that, we used Delta Live Tables. So we're still using Autoloader. Autoloader is the tech that we're deciding how to work out which files that we're actually loading. But we're using Autoloader inside of Delta Live Tables. So pulling together some of these different Databricks technologies into this kind of coherent system. And then finally, we built a quick dashboard on top of it to show you about how you expose that, how you write SQL on it, how you do some analytics. So we've been through that process just to kind of show it's fairly easy. It's fairly easy to set this stuff up. It's fairly easy to go through that process and build out essentially a nice SQL warehouse layer, but it's in the lake, and you can go build it from there. So we thought for this session, we'll just open the floor to an AMA. If there's any of those bits that you want to dig into and go, actually, I didn't bother watching the series. What's that? How does that work? We can talk about it. If there's any other bits that you're like, well, actually, how does this scenario work? We can talk about it. So the main thing is questions.
Yes. By the way, I've logged in if you want.
Oh, and we have a laptop that works with the internet. So we can show it if we need to.
Exactly, yes. But we do want questions first. But by the same token, yes, that's exactly it. We actually can show it now.
Cool. So what do we have? Do we have any questions ready to go?
Sure. Boom. Yes.
So I'll embarrass Yulia here. We work together. We're working on a consulting project for a credit union, and we're working with form data that's XML. We're using Azure Data Factory to put it in Cosmos DB, and there's a Spark connector for Cosmos DB to load it into Databricks. And we're running into some performance issues.
Yeah.
Yes. And so is there any insights that you have to get better performance? Should we not be using the Spark API to pull data out of Cosmos? What might work a little faster for us?
I can tackle part of it at least.
Okay.
All right. So first of all, which version of Spark are you using with the Spark Cosmos DB connector?
The latest.
The latest? No. Okay.
So
the latest connector, but which version of Spark or Databricks are you currently working with?
Oh man, it's pretty recent. I don't remember the exact one, but it's not old.
Excessively long story short. Okay. The Spark connector that's currently public with the Cosmos DB, if I recall correctly, is working on Spark 2.4. Okay. That'll actually have some performance issues when you're actually working with a later version of DBR because of Spark 3.3. There's a bunch of both 3.2 or 3.3, depending on if you're using the beta or not. The configuration specifically with the Cosmos DB connector, because of the way it's actually operating with the version of Spark 2.4, it's actually going to run slower when you work with Spark 3.3, 3.2, because of the configurations we put into DBR specifically to for example, like AQE, for example, right? That'll just run faster with it. Now, it's my understanding with the Cosmos DB team that they actually have a version of it that's supposed to work with Spark 3.x, but it's not public yet. But there are specific customers, to my understanding, that are currently using it. By the way, I'm formerly of the Cosmos DB team, so that's the reason I know all this stuff. Okay, so now saying all that, the key concern that you're still going to have when you're extracting data out of, even if you're using the latest version of the driver, pretend it's Spark 3, everything's good to go. The usual problem that you're going to have is, number one, you're going to have to knock up the number of RUs to a really high number in order for you to be able to read fast enough out of Cosmos DB. Even if you're trying to use something like HTAP or whatever else, doesn't matter. You actually have to have the RUs at a pretty high number in order to extract it out. You're going to immediately tell me, dude, that's a lot of money. And yes, that is the correct answer. So what you're going to want to do is basically knock up the RUs long enough just to do the extraction and then knock the RUs back down almost immediately. So you can code something like that so you can save a bunch of money. Once you do...
I'm going to disagree there.
Oh, sorry?
Oh, I'm going to disagree.
About saving money or?
No, saving money is good.
Okay, sorry.
So for me, I wouldn't try and query the whole of Cosmos DB. I'd switch onto the change feed. You want to pull out updates from Cosmos DB rather than try and hit it and query the whole thing, which Cosmos DB is not great at and going to cost you a lot of money for doing a big analytical query. Yeah. Just take the change.
No. Okay. So we're actually in agreement.
Okay.
No, we're actually in agreement. No, I was just talking about, in the end, you're still going to knock up the RUs in order to be able to even get the change feed.
It's true.
You have to admit that. Okay. All right. All right. So either way. And yes, I agree with him fully. You should hit the change feed. Okay. Now, the context is that even after you do that, though, is that what's happening is that the data may not be in the same partition format that you actually want to put it into whatever, whether it's Azure Data Factory, into a Parquet table, a Delta table, I don't care. I'm not trying to pitch one or the other at this point. Obviously, I prefer if you're using Delta, but that's just me. But in all seriousness, the partitioning scheme that you actually extract the data out of Cosmos and the partitioning scheme of the table, or even just Spark in memory, often will be different. So you may actually need to repartition the data in memory for Spark to actually query it in an optimal manner. Okay? So there's, especially with the change data feed, that'll be the problem, because what you're doing is you're actually extracting out small little tidbits of transactional data at any point in time. If you're then trying to, for example, query that little bit with the historical context, that's actually completely different partitioning schemes, typically.
And that's probably a good idea, because I actually partition my Cosmos container to be to the day. So we're knowing exactly what new data is. So we could move to that to save on RUs and money to do that. So yeah.
So between the day and also specifically, again, to Simon's point, the change data feed, I think then you'll be able to reduce the amount of RUs you actually need to extract out the data. And then what'll end up happening is that you'll still most likely, because you're doing historical query contexts, right? You'll probably need to repartition, but you can do that in memory with whatever the data frame is. So that way it'll actually speed up your query performance that way.
Thank you.
No worries. All right. Good deep questions started off. Any more questions? It's an AMA. We need more questions.
Yeah, exactly. And we like I said, we like deep technical questions too. Oh, there's a question there. Cluster's working.
Yeah, we can switch over now.
Oh, just sandwiches.
So your bronze, silver, and gold Delta tables are over top of Data Lake.
Yeah.
So why land your data uploads from Data Factory into blob storage instead of just landing them straight in Data Lake?
Cool. I can take that from a design pattern.
Absolutely, go for it.
So we kind of started implementing a separate landing area for a few reasons. Firstly, so this is a very Azure answer to the question. If we can use it in blob storage, we can kind of change the security configuration of it. So we have like the full lake, the ADLS Gen 2 lake, where we can have like a certain level of replication. We can decide maybe we don't want to turn on geo-replication for the lake because that's a lot of money to spend. But having a separate blob store, which is just a glorified staging area, maybe we can turn on kind of geo-rep and then use that as a restore point for the rest of it. Maybe we federate out the blob storage and we can give access to different vendors who are sending us data. And that is just kind of almost this kind of like little DMZ abstraction layer about things getting into the lake. But also so we can use things like Autoloader. So I prefer to actually, we get questions quite a lot in terms of, actually the diagram's wrong because it says Delta, it's not Delta in landing. So we normally just land the original file type into landing. And we get lots of questions from people who are extracting from a SQL database or extracting from a structured type. And we go, great, okay, you're going to take that, and then you're going to remove all structure and put it into a landing area, and then we'll pick it back up and put structure in. And they're like, what? Are you insane? Why are you doing that? And for me, it's all about schema evolution, schema drift, all that kind of good stuff. So these days inside of Autoloader, you can do things like the rescue-style schema evolution. And you can only do that when it's reading on unstructured files. So it can only do it on JSON and I think delimited text now.
Correct, right now, yeah.
So you have to take away the structure so that you can compare it to another structure to say, has it changed? So if a vendor's sending you data and then one day you get an extra column or it's a bigger data type and you're protecting yourself against schema drift, we can handle that in a structured way as part of the thing. And that's why we have that separation of that's not really part of the lake because that could be, those files could be incorrupt. They could just have sent us garbage. That could be a massive changed file. And then when it's in the lake, it's because we've picked it up and put it through a data frame in Autoloader, we've got structure. So that can be Delta all the way through and we've got all the good governance, we've got all the good ACID transactions and all of that stuff.
Yeah, and one thing I would actually add, just to provide some additional context here, is that when it comes to those DMZ zones, often you're not the one controlling it, right? It's often controlled by some other, like not every company operates this way, obviously, but there are plenty of companies, what they do is that the DMZ, basically the pre-bronze in essence, that's controlled by IT or controlled by some other organization anyways. So the fact is, you don't actually, in essence, you don't want to trust the source. You just assume that it's a dumping ground, and then you treat it as a unsafe source to begin with. Maybe that's a little too strong, but the context is that basically you're not pretending the schema is correct. You're not pretending the data is even correct. You're going to validate it before it comes in. So
essentially, after years in data, we're both so pessimistic that someone's going to send you garbage data.
Yes.
We protect against it. It's kind of the plan.
Understandable, yeah.
Yeah.
Thanks.
All right. Another question?
Repeat.
Right.
Sorry.
So so do we run Autoloader as part of the Delta Live tables is the question. I mean, we went over that at the start, so paying attention, just terrible. But yeah, so when you're using Autoloader, essentially you use it as it's a file type in structured streaming. So you can say, I want to make a data frame. That data frame is going over format cloud files. And if it's cloud files, then that means it's Autoloader. And so all we've got inside our Delta Live tables job, the first table, it's actually it's a view that's doing the Autoloader bait and kind of the demo we put together, I think.
Yeah, I think so.
It's been a while.
Yeah.
That's calling a cloud file source. So Delta Live Tables is using Autoloader to bring data into the context and give it some structure, and then from then on it's just landing it as Delta tables and streaming it through from there.
Yeah, the one thing I definitely would like to add about Autoloader specifically is that even though all you're doing is saying cloud files, actually what's happening beneath the covers basically is that there is actually a delete queue and a read queue on all the files. So in other words, we're keeping state of every single file that's actually being placed in the blob storage or to wherever you're putting it, right? And because every time you're doing a file listing, okay, on blob storage, that's extremely slow. So what we're trying to do is we're trying to avoid that particular problem by basically building up, in this case we're using RocksDB, to basically keep the state of what's the read queue and the delete queue. The delete queue basically says, okay, I've done processing that file, now go delete it, okay? Or in the read queue, I need to go ahead and read that file. So as opposed to you needing to keep the state of all of these different files, Autoloader basically takes care of that for you. All you did was basically specify cloud files, but basically underneath the cover, it's automatically taking care of all that. So hopefully that clarifies that, the reason why we want to do that, and how that's actually separate from DLT from an orchestration perspective.
I have a microphone.
Oh, okay.
Hi, sorry, I'm just going to I'm going to jump in. So just a quick comment before my question. I love your YouTube channel, and thank you so much for all of the content you create.
Thank you.
I feel a lot smarter for watching it, and I'm actually a Databricks employee as well, so thank you for that. So now I've got a couple of questions about this. So I build a lot of demos, and I've built a thing exactly like this, actually. I just wonder how, so you use ADF to get your JSON data into the cloud data lake.
Yeah.
Do you have other tools that you've used that are really good for polling REST APIs, like random REST APIs? I find myself doing it all the time. Like ADF is kind of a bit of a heavyweight tool for that.
Yeah.
Can you recommend any other tools? And then the second part of the question is, can you just explain a little bit about how frequently the JSON files are dropping in here in this example, and how many, how often, and how Autoloader handles all that?
Cool. All right. So to question one, no. No. I mean, a bit of context there is because most of our clients tend to be Azure clients. Most of our clients are already doing some kind of cross-network shifting of data. They're getting data from their corporate network. They're pulling it into the cloud. They don't want to do all the networking plumbing of making it so Databricks itself can see all their internal systems to do a pull directly. So we nearly always end up having Data Factory in our Azure implementations just to do that. And if we've already got it, we've already bothered deploying the infrastructure, we've already got the DevOps to actually get it there, we just use it out of almost laziness of not setting up a different thing that we have to secure differently and look after. Now, there's been obviously a big focus on lots of different integration tools, and kind of Fivetran's been talked about a lot.
Exactly.
I don't have any experience with it.
Yeah. So in general, you can actually look at a lot of exactly like what Simon called out, like Fivetran, DBT. There's all these other integrations that actually work really well. And for that matter, honestly, you can even just especially if you're just reading a REST API to grab it, literally you just do a Python calls, right? And distribute with Spark for that matter. You can literally go do something like that.
That's what I've been doing. I think like Fivetran seems to be good if it's a really popular, well-known API. Yeah.
That's true. It's very true. And but in the end, it's more. It literally is more a matter of like it's your preference more than anything else. Just like what Simon's talking about, his customers in his environment is typically going to be doing ADF as it is in the first place. Honestly, most of my customers, they're just going to code it themselves, right? So they're literally going to either write a REST API or they're going to write a Python API to go ahead and do the queries anyways. So it literally is to each his or her own.
Yeah.
Yeah.
And in terms of how often you run this thing, I mean, that's the nice thing about, so whether we're using Delta Live tables or whether we're doing kind of, so we build a lot of the stuff ourselves and the big PySpark scripts and we just run it through, but we use the same pattern. So we use Autoloader to going from a landing area to pull data into our, what we call raw bronze medallion architecture stuff. And then move it from there, we stream from that raw table into like a cleaning table. And so essentially kind of that area, Autoloader itself is a streaming technology. Delta streaming is obviously streaming technology. So you can leave that turned on. And then literally whenever someone drops a file in, that'll automatically just get ingested. And so your latency, you're talking about a couple of seconds. Or you can switch it and say, I want to use trigger once or trigger available now. And that's you kick it off like a batch job. And it still does streaming, but initializes the stream, works out, has any files come in since I last ran? If so, processes them, and then it shuts down the cluster, so you're not paying for it to be there all day. But the nice thing about that pattern is, so maybe you've got like an overnight ETL load, good classic BI warehouse overnight load, and you do that, and you just kick off this job. Anything that's come in during the day, you'll process. And then they go, ooh, actually, could we start doing it hourly? And you just change the schedule. There's no code change, because actually it's just all whatever's happened since I last ran, and it just gives you the flexibility of you can run the same thing every 5 minutes, every hour, every day with no code changes, which is great.
Right. Yeah, so for example, one example that I like using, especially when it comes to structured streaming, especially talking about that trigger once concept, right? So for, one of the examples we used, I think a couple of years ago pretty heavily was Comcast, right? And what happened is that they were trying to take the set-top box information. And so they used to have, by basically using structured streaming with trigger once, and with Delta Lake so they can ensure transactional reliability of the data, they went from 640 VMs down to 64, and by using the trigger once, they went from 84 batch jobs down to 3. So, and also their latency dropped at least half. So basically, that's all they did. They actually changed none of their business logic. They just simply said, we'll simply switch the trigger once, and that basically simplified the process, and they were able to use 10x less VMs. So it seemed like a pretty good win. So.
And the trigger available now is the new flavor of
Yes,
trigger.
that is currently the new flavor. That's fair enough. I'm sorry, I'm still an old guy, so.
I haven't changed it in all my implementations, honestly.
Yeah, I know, but still.
But it used to be, if you use trigger once, that would try and load everything that's happened since as a single micro batch, which isn't the most efficient thing in streaming to suddenly get this massive peak of load of data. Whereas available now actually goes, right, I'm going to start, I'm going to keep doing micro batches until I've caught up, and then I'm going to stop. So it's actually just a slightly more efficient way of doing the same thing. So you've now got control over, I want one big glut of a thing, or I actually want to just, I'm still trying to do the same thing, but just do it efficiently.
Yeah, basically it doesn't mean, what ends up happening is that you don't actually need to spike your, for example, if you're doing auto scaling, you don't really need auto scale anymore. It's just more like, no, just go ahead and keep it at that pace instead. So you're using a lot less resources, a lot cheaper. So yeah, fair enough.
If you want something lighter weight, then Data Factory and Azure Functions is also a good choice.
Yeah.
Azure Functions.
Just write a bit of code to do it, yeah.
We use it where you can't, where you fall off the edge of what Data Factory can do, and then you have to do something custom in a function. So you can just do it with a function.
Yeah, writing horrible little paginated loops to page data out of it, it's a meh, yeah.
Perhaps a difficult question about Autoloader. Is there any good way to figure out what Autoloader has loaded already? Like report on it?
That one I actually do not know the answer to, mainly because I know we were supposed to be updating Autoloader to actually provide additional monitoring reporting, but I don't know the current state. Now, in terms of the actual information, in terms of it's already in the RocksDB database itself. So in other words, you can actually track exactly what the read queues and what the delete queues are exactly at that time. I just don't know what the current state is in terms of like how much the reporting is coming out. So
That'd be a cool demo video.
Sorry?
That'd be a cool demo video.
It would be a cool demo video. So you know what? Just ping me off the side, and I'll make sure that number one, we do that, and number two, actually, I'll also be able to check with Barak. So he's the lead for the Autoloader project. So I'll just smack him up and get the answer. So,
and from our less technical, just build it into the process thing, we just automatically stamp all records going through into the raw area with the input file name. So actually, we can just do a select distinct of all the different files so we get our own list. Not as good as being able to just pull it straight from metrics logs, but as part of the process, we know what's been loaded, and we can always tally it up and go, that's what I think I've loaded, that's what I haven't loaded, and kind of matches. We did have, so we had a couple of pre-questions put in, and I did have one question, which is one of the worst questions for Autoloader. I'm going to give to Denny.
Of course.
What happens if the file, you want to reload a file in Autoloader?
Okay, by definition, when you try to reload a file, it's not supposed to be able to process it again.
Yeah.
It's by definition not supposed to. Yes. But you're about to tell me something else, right?
And you can say that never has a client ever had a scenario where they need to reload a file. So there are some patterns now where you can force it to catch up.
Yes,
you can
force it to
reload
catch
that
up,
area.
yes. And admittedly enough, in the past, we did things like where you actually rename the file in order to do it.
Yeah, it's
which
like
I
delete it and
realize
reload it. Yeah.
That is an anti-pattern, by the way. Do not do what I just said. But I'm just saying that was one of the workarounds we did in the past. Yes, nobody needs to reload a file. What are you talking about?
But it's honestly a conversation I have with clients when we say, hey, look, we love this autoloader approach because you no longer have to wonder about, running a job and saying, look for files that match this kind of file pattern and building a whole watermarking metadata thing to try and work out what files you need to load. You get rid of all of that complexity, but you do add other complexity. Other things are slightly harder, reloading a file, which comes up occasionally. Yeah, it's not that elegant a pattern, but that's kind of one of the things that you're getting by saving all the other time in terms of doing that file matching ETL stuff.
No, that's fair.
So there are one or two things that become more complicated if you're letting it do black box. If you're saying, I trust you to manage things for me, occasionally you need to kind of just play the game and reload a file.
Yes, agreed. And so then I think what you're doing is you're asking me to act as the product manager in this case, and to go ahead and make that much more clear. Is that what you're asking me?
Yes.
So you're just doing it live, asking me. Okay, cool. All right, fair enough. All right, that's fine.
I thought that'd be fun.
No, that's fine. I'm cool with it. I'm cool with it. It's okay. Since the product management team isn't here anyways, I'll just forget it anyways, so it's okay.
Well, you are Databricks.
Am I?
No,
look at me. Look at the shirt I'm wearing.
All right, more questions.
So is the main kind of advantage of not using structured streaming and trigger once and using Autoloader to basically bypass the file listing operation because that could be pretty expensive.
Yeah.
Yeah.
I mean, it simplifies it, basically. That's the key thing. So, sorry, just to repeat the question so everybody hears it. Basically, the main advantage of Autoloader is that basically you don't have to worry about the file listing. So you can, in essence, for example, if you wanted to do this yourself, basically off the storage system, there's basically there's a queue mechanism that can give notifications of when a file drops into the storage system. You can, in essence, then take that notification, store that in a queue of some type to basically track which files that you need to process, okay? And then once you go ahead and finish processing that file, then you can go ahead and remove that from the queue so that way you know that you've already processed the file. Or you can let Autoloader do everything I just said.
And I mean, if you're treating it as like a daily load thing, that's like a tiny advantage, right?
Yes, correct.
It's going to take, it's not going to take 10 seconds doing a file listing. It's going to take a millisecond. That's not that big an advantage. So Autoloader itself, on that purity, it's great if you're streaming. It means your micro batches and you're constantly doing it way faster. But for the kind of daily load trigger once thing, it's not adding that much from just the file notifications. But actually, as then kind of built on top of Autoloader, you've got a load of schema management. So actually, when it runs, it'll infer the schema, and it can land a file that actually has the schema metadata. So you're not having to have a separate metadata thing and work it out and keep it yourself and tell it what structure to have. It's just going to manage it as metadata next to the file. And then it's got some mechanisms in there to go, the data's changed, let's kind of stop and restart it and update it. Or the data's changed, let's dump it into an unstructured column so people can query the extra data without having to change the actual physical structure. So started off just as a pure optimization for that file notification queue. Now it's got a few bits of functionality baked on top of it that just make any kind of ingesting weird and wonderful data from files just a little bit better, a little bit simpler.
Yeah, exactly. Yeah, and then basically the most common approach basically is that rescue one, where basically because the schema has changed, but you still want the process to continue running, you don't want it to stop, then basically there's literally this, the column literally by default is called _rescue. So you basically can query that column. That's where the unstructured, semi-structured data actually sits, where you can then query it to figure out, like, was that schema actually valid or not? And then you can basically offload it, go back, and then in your bronze table, go ahead and do an update to the table to add the schema or whatever else you feel is appropriate. So.
And that, it's kind of like it's, so it used to be the data's changed, you have to go and update the table. Right. It's like it stopped. You either physically update it right then, and then you forever have the extra column. Yeah. Or you chuck away the data, you never get it.
And neither option is valid, right? I mean, there are definitely times where it makes sense to change the schema. There are definitely times where you're going, no way, this is complete garbage, right? Because I actually received the wrong data sets altogether, right? Yeah. So the whole point is that we simplify that process so that way you allow the process to continue running. This is even if you're talking about batch processing, but just frequent batch processing, the whole point is that you don't want the job itself to stop in a production environment. You want it to continue running. And so now in the end, the important, and I think part of the reason why we keep talking about this stuff is because it really does depend on what your business logic is, okay? In other words, some people are gonna say, no, I need it to stop. Minimally, if that's the minority. The vast majority are gonna be doing a version of like, okay, no, go create the rescue column, or you know what, allow the schema to go through, or, right? There's gonna be multiple answers to that question. So it really depends on your particular environment. And for that matter, different customers, a single customer could have like, depending on the table, have different ideas of what they want to do with that data, so.
And I guess the other thing to note is if it's in the rescue column, it's not going to get delta stats. It's not going to be file skipping. It's not going to be performance.
It's JSON string, so we are not remotely.
So people can go in and query it. So it's great from an analyst going, actually, is there any value in this new random thing? And going, oh, that's really useful. I'll bring it into a report. Right. And then they go, can we get this permanently? And then you need to make a physical update to the delta table and say, this is now a first-party part of my table. Yeah. But it means you've got control about when you do that. It's now a process about when should I include that as opposed to, oh, it's broken, I need to fix it right now.
Because we don't want to generate stats on strings that you actually don't need. No. Because then that's just going to take up both processing time and space, which costs money. So that's a bad thing. Yeah.
That's fair. Yeah. All right, more questions.
Sorry. Yes.
So I'll keep this quick. I know we are at time, but real fanboy moment because I'm a Databricks SA, and I think a lot of credit goes to you guys for your videos on YouTube for that. So thank you. So I have a very specific question, and maybe this is too detailed, so we can do this offline as well. But when it comes to Spark structured streaming, what my observation has been that does the Spark behavior change depending on the sync that you have? So in my example, what's been happening is I have a delta table. I use that as a stream, and then load it. If I'm loading it into another delta table using max files per trigger equal to 1 setting, it works just fine. But if I am loading it in Cassandra, and this is one of my customers, by the way, it behaves like poorly. It's like super bad. Is it usual? And you mentioned something to do with Cosmos DB. So is it depending on the connector as well?
Okay, so there's no simple answer to this question. Okay, so let me try to at least like bubble it up to a more generic question. Okay, when it comes to using any streaming system, this is not specific to structured streaming. It's obviously applicable to that, but I can give you the same answer for Flink. I can give you the same answer for Pulsar. This is not a knock on any system. This is just saying, in general, when you have streaming systems of any type, the idea of writing to one storage versus the other is going to result in, at times, very, very different contexts and performance structures. Okay, so for example, structured streaming to a Delta table. Yes, that is beyond optimized because that's frankly how we built it. Okay, so that is relatively straightforward. The reason why is because it's writing to a Parquet file in the first place, which is what Spark was designed to do in the first place. We just simply added transactional semantics so we can ensure the transactional reliability of the data. Okay, bam. So you add a little bit of extra, a few milliseconds of extra time, but you ensure transactional reliability, no corruption of the data. Perfect. Okay, now I want to talk to Cassandra or I want to talk to Cosmos DB. Okay, problem number one. When we talk about exactly one semantics, we're in structured streaming. Exactly one semantics means from the source at the point in time that we read it to the point in time where we're just about to write it. But we actually haven't written it yet. Remember, it's in the data frame, we're about to write it. That's the exactly one semantics I'm talking about. In other words, when we process the data, when we see it once, we only process it once. If we see it again, we won't process it again. Okay, that's what we mean by exactly one semantics. Now there's the problem of actually writing it to the end state, okay? Now again, because Spark is designed really well to write to Parquet in the first place, having to write to Delta, and actually to give credit to my competitors, okay? To Iceberg, to Hootie, it's designed for that purpose, okay? So it's very well designed for that. When it comes to writing to, like for example, a document store or a key value store, like your Cassandra or Cosmos DB, the reality is those systems often will require some form of like a partition key, or they're going to require some form of document ID that allows it to distribute it correctly. Well, if your data, for sake of argument, is partitioned by, let's just to oversimplify the problem, partitioned by date and time, okay? So in other words, you've got 5,000 rows and they're partitioned by the hour, let's just say, okay? But the document store itself is partitioned by country, for the fun of it, okay? That alone is basically going to force one stream to take on the vast majority of the writes, and the rest of the streams are basically running idle. Okay? So each one of these environments, there's going to be two things that are going on. One is what is actually the partition key, primary key, document ID, whatever system it is, that allows for that distribution. The second thing is definitely the configuration itself. So in other words, just like the original question about Cosmos DB, if you're using a Spark 2.4, but you're actually a connector, but it's actually running on Spark 3.3, yeah, AQE configurations are going to completely screw this entire thing up. So even if it's trying to write to Delta, it's still going to screw it up because we were trying to actually distribute the data in one particular way, and it completely doesn't work. Right? Then we're trying to go ahead and write to, like, a Cassandra or whatever else. Well, again, which version of Java? Which version of Scala, okay? If you're using Scala 2.11, which a lot of systems are using, that means I can only handle up to 12 columns, well, sorry, 24 columns. Anything above that, all of a sudden, basically, it's paging in memory. It might be able to handle the 36th column, but guess what? Now, basically, the driver's full of memory, it's ooming to death, and basically, your performance just drops massively. And I'm going to stop now because I just realized I'm rat-holing out of hell, but the point is that every single one of these things are going to act a version of what I just said. Okay, so as much as I'd love to say there's a simple answer, as you can tell how I've already rat-holed beyond belief, yeah, it's complicated as heck. And so that's the main reason why, because the way a doc store works and the way a file system works are inherently different, and how you optimize for them are also inherently different. No. Yeah, basically, I should have just said that. No, there's no easy answer. So my apologies.
Yeah, take the recording, just play that back.
Yeah, take the recording, play it back. They're like, okay, got it. You know what? I don't want to know the answer. I want him to shut up, right? So that's fair. Okay.
And you just dropped AQE in there?
Yeah. Well, I always drop AQE because I love AQE. Oh, sorry. Was there a question about that?
No, but you're just dropping acronyms. You need to explain the acronyms.
That's right. I'm sorry. Okay. Sorry. Spark 3.x introduced a concept called AQE, Adaptive Query Execution. So the whole purpose of Adaptive Query Execution as part of the Spark.3.x line is that as opposed to when you create when you look at the Catalyst engine for Spark, there's what they call initially the logical engine and then the physical engine. Okay, so the logical engine basically builds up a bunch of logical plans. This sounds like a database system because that's literally where we took the ideas from. Okay, and you build up a physical plan. The physical plan then basically says, okay, I'm going to execute these RDDs in a particular way to basically give me optimal performance. The reason I have a logical plan first is because I'm saying, for example, oh, maybe I should filter the data before I do the join, so that way there's less data for me to join, okay? That's why we have this concept of a logical plan versus physical plan. Now, I can probably ask the question, you guys can go for hours, how many times does the statistics or what the prediction of how large a particular join table is works out perfectly? So you probably know the answer is not even close, okay? So what's happening with AQE, Adaptive Query Execution, is that what's happening is that when we read the stats, when we actually read the data, we recognize, oh wait, the join table is actually significantly smaller. If it is, then I can do a broadcast hash join versus a shuffle merge join. So what ends up happening is that in the process, we change the join from a standard shuffle join to a broadcast hash join. That will speed up the query performance. You don't have to do a thing, okay? So as part of DBR, I forget which version, 10.1 or 10.2, but one of those versions, basically, we automatically enabled AQE because that was part of Spark 3.0.1, I think. And so because of that, that will obviously speed up performance, but assuming everything's operating under the Spark 3x line. And then the other really cool thing, which I'm going to stop real soon, is that also it's actually able to handle skew joins really well. So basically, AQE automatically goes in and says, hey, your data is skewed. I'll automatically subpartition the data, so that way I can go ahead and speed up the query performance, so that way you don't have one or two long-running stragglers. I can probably shut up now, right?
Yeah.
Perfect. All right.
But I think that's us out of time.
Are we?
We got 4 minutes?
Okay.
Yeah, go for it.
I'll let him talk now.
I'm just wondering, do you have any suggested best design practices for, I forgot it, migrations, like transferring that concept into the bronze, silver, gold, and as far as I can tell, the best thing is picking where you don't have to change and reprocessing and completely overwriting everything. But if there's just a good design pattern around it, I'd love to hear.
I mean, yeah, the easiest thing is to lift and shift, and you can basically just bring over a lot of your existing code. You know, so if you, it depends on what you were, it depends, consultant answer. If you were coming from something that is heavily SQL-based, and they had a load of SQL stored procs, and that's how they were doing all the facts and dimensions and things, yeah, you can take a lot of that logic that you had in stored procs and just bring it over, run it in Spark. There'll be a minor bit of refactoring to make sure it's happy in terms of, you know, the Spark SQL language, but you can run it kind of that way. It's not amazing. You know, because if you end up kind of, if you're loading, what, kind of 50 different assets and you end up with 50 different SQL notebooks and you have to manage that, that's not great. What we end up doing quite a lot is taking the SQL logic and then kind of wrapping that in a much more generic framework. You know, so if you could say, if the SQL wasn't crazy complex and nest views on views on views on views on views, and you could store it just as a SQL view, and then we just have a bit of a PySpark, and we go, right, loop over this list, take these 50 things, run these 50 notebooks in parallel. So you're running the one notebook with parameterization. So you can kind of mix and blend. So you're keeping your business logic in SQL where you already had it defined, but you're just wrapping it inside Spark and then kind of just run it. That's what we end up doing quite a lot.
I actually meant created pipeline in Delta Lake, and now you change what you're doing in Delta Lake. So not moving from an existing framework.
Sorry, so you've changed which bits?
You're evolving, say, how you get to gold. You've added a new analysis that adds to the table. And so you've got more columns of the data.
So how do you manage change control of your curated assets in a Delta Lake scenario? Yeah? I mean, I know there's lots of DBT things that kind of work on that to try and give you that kind of slightly more controlled engineering experience. Again, haven't done too much of DBT myself because we got our own patterns and ways of working on it. The main thing is treating it like any other code asset. Treating it as something that is actually stored in source control, is deployed automatically. Again, that separation that I was saying in terms of having your engineering framework separated from your SQL transformation logic and treating that as basically just a metadata input protects you a little bit from having to redeploy your code and doing all that change because you're abstracting the physical, just take something, change it, land it, that's not going to change. It's your actual logic that's changing, and if that's all rule-driven, that's held separately, you're kind of buying yourself a little ability to kind of separate it. And then in terms of kind of managing the actual physical object changing, it depends on the object. I mean, if it's getting extra columns, if it's upscaling data types, Delta can do that. That is just a schema evolution of Delta. If it is, okay, we've completely changed it, we've renamed all the columns, it is kind of a drop and reload and kind of reprocess it, and you have to take that hit. But it's kind of just having the processes built in so you can know when those changes are and you're kind of putting it through the process. You should be going through a dev, test, UAT kind of scenario anyway, because it's a solution that we're building. So kind of just managing it that way.
Yeah, and one small thing I would add is don't forget there's user-defined metadata that you can go with your transactions. So a common actually pattern is because you're putting your code base in GitHub anyways, you can do the associated GitHub branch. The ID for that particular branch, in which when you make the change to the code, and associate that with the transaction changes to your table. So that way, your table literally points to the code base that actually says, okay, this is where I made the change. So
that's pretty cool. We don't do that. We should do that.
You should do that.
Yeah.
Yeah, I know. See, I've been talking about that too.
Taking some notes.
Okay. All right, we got. Do we have time? Yeah. Okay. Maybe one question.
Yeah. Before I ask, do we have to leave the room, or we have time to stay? I don't know. Okay. Yes. Thank you. So I wanted to take your advice on vacuuming. Recently, we've been vacuuming, and we realized it takes a lot of time. And the feedback we got from Databricks was because vacuuming is doing that ls list of all the files, and that's the part that takes a lot of time. Mm-hmm. And I was wondering how we can bypass that while doing vacuuming, or any advice you have in that action.
Okay. Now, without rat holing. There's actually two things before you even do that. While I agree the listing is actually problematic, what may actually be happening for you, in fact, there's a GitHub issue which I don't remember the number, but I'm actually in it, okay? What happens underneath the covers is that it's actually referring to a particular Spark configuration which automatically defaults to 20,000, okay? I forget exactly which one it is, but that's the number. And the reason I bring that up is because all we did was knock that number to 100, and basically the vacuum went about like umpteen times faster, okay? So part of the reason why was because Spark was itself automatically wanted to run multiple threads to validate the data. But the thing is that if you're only dealing with a small amount of data in the first place, like that would work great if you're talking about petabytes of data. But most of the time when you're vacuuming, you're not trying to vacuum petabytes of data. If you do, honestly, you have a whole other problem. Okay, so what ends up happening is you knock the number down. So just ping us on Slack. I'll actually tell you exactly which GitHub. It's just I don't happen to have that in my head. Now, the second part of it, though, is that even if pretend you knock down the number, there's these issues. Don't forget that you can actually spin up a second, smaller cluster that actually can run the vacuum in parallel. Okay? So even as you're doing inserts and updates and modifications, you can actually run the vacuums in parallel. This is actually a very common approach when it comes to streaming, where basically you have lots of little small files. You don't care about the historical context because the small files actually already has it. So what ends up happening is that you're basically running the compaction, and then you're also running the vacuum with a separate cluster, so that way, it's a smaller one, so it's not costing you that much money, to basically go and shrink down the file size. By doing that, you actually will shrink down the number of files that are actually physically inside your storage system, which by then, very definition, even if I have to do a list, the list is significantly faster.
Thank you.
And that separate cluster, I'd normally just have running under a Databricks workflow, not a job. And then you make it a job cluster. So it's just leave it nice and cheap. So even if you're using an interactive cluster, which we do quite a lot for parallelism,
that's true.
Just to spin up one cluster and then fire loads and loads of things at it in parallel, try and jam them together. We can run a separate thing as a job cluster just to keep the maintenance nice and cheap.
That's true. Very good. Yeah. Ben?
All right.
I think we're good, right?
I think we're good.
All right. Thank you very much.
Yeah.
Thanks a lot. Cool.